Hello everyone, welcome back. This is part 5 of the Solid Design Principles tutorial. In this session, we will discuss Liskov substitution principle, implementation guidelines of Liskov substitution principle, and will implement this principle with a simple example. Please refer to the previous parts of the tutorial before proceeding. In the first session of Solid Introduction, we have understood that L in the Solid is acronym for Liskov Substitution Principle, which is also known as LSP. Substitutability is a principle in object-oriented programming, and it states that in a computer program, if S is a subtype of T, then objects of type T may be replaced with objects of type S, which means derived types must be completely substitutable for their base types. More formally, the Liskov substitution principle is a particular definition of a subtype relation called strong or behavioral subtyping. This principle is introduced by Barbara Liskov in 1987 during her conference address on data abstraction and hierarchy. This principle is just an extension of the open-closure principle. The examples used in this session are related to the open-closure principle. Hence, we strongly request and recommend you to watch the open-closure principle tutorial before proceeding. Now let's take a look at the implementation guidelines of this principle. In the process of development, we should ensure that no new exceptions can be thrown by the subtype unless they are part of the existing exception hierarchy. We should also ensure that clients should not know which specific subtype they are calling. The client should behave the same regardless of the subtype instance that is given. And last but not the least, new derived classes just extend without replacing the functionality of the old classes. These are some of the implementation guidelines of Liskov substitution principle. I'm sure that it's a little confusing at this moment, but I can assure you that it's very simple to understand and it can be easily achieved using a simple example. Now let's switch to Visual Studio and see how we can implement the Liskov substitution principle. In the previous session, as part of the open-close principle implementation, we have created different employee classes to calculate bonus of the employee. We have inherited the employee class into permanent and temporary employee adhering to the open-closure principle. From the employee perspective, we have implemented successfully the open-closure principle. Now let's switch to the main program, and if you take a look at the main program, we have created employee objects consisting of both permanent and temporary employees. Also, if you take a closer look at this program, the derived types, which are permanent and temporary employees, have completely substituted the base type employee class. So based on the Liskov substitution principle, we have achieved this by ensuring that derived classes are completely substitutable for their base classes. Also, if you notice the main program, without using the subtypes, we are calculating the bonus of the employee from the base class itself. Hence, we are satisfying the Liskov substitution principle. That means, along with the open-closure principle, we have partially implemented the Liskov substitution principle. I reiterate the word partially because this implementation is error-prone, though the basic principle is implemented. Also, I can state that this implementation is not adhering to the guidelines of Liskov substitution principle. Now, to understand why it's not adhering to the Liskov substitution principle, let's make a small change in this sample application. Let's switch to the employee class. And now let's assume that we need to create a new contract employee as one of the employee category. So as a typical programmer, I tend to create a new class, public class contract employee, and I will inherit the employee class, which is a base class. Let's implement these abstract class methods. Let's add constructors to this contract employee class as well. Now, a point to note here is Contract employee is not eligible for any bonus calculation. Hence, I'm throwing an exception over here in the implementation of calculate bonus. Now, as part of abstraction, if we need to create a contract employee in the main program and try to compute the bonus, let's see what happens. Let's switch to the main program and let's create another employee, and I would say call it as employee Mike. Let's make it as Mike, and let's also print the Mike's details. Let's say employee Mike.toString dot calculate bonus. Now, instead of temporary employee, let's change it to contract employee. Let's run this program. Notice that though the compilation succeeded, it has thrown a runtime error in the calculate bonus computation. Now we can state that this part of the program is violating the implementation guidelines of Liskov substitution principle, which states that no new exceptions can be thrown by the subtype. Now I believe you are very clear at this moment with my statement that we have implemented the Liskov substitution principle partially. Now to correct that, let's rewrite this code in a different way to adhere to the Liskov substitution principle implementation guidelines. Let's stop this application. To make the things faster, I have already created a new interface called iEmployeeBonus consisting of interface method calculateBonus. Now please note that the calculateBonus is part of employee base class till now, which we have moved it to iEmployeeBonus class. Along with this interface, I have created another interface called iEmployee and added a new method called getMinimumSalary. Now coming back to the employee class, to make the things more structured, I have moved the classes of the employees and the respective files under abstract and implementation folders. Now let's take a look at the employee class. In this class, we are inheriting both the interfaces of iEmployee as well as iEmployeeBonus. Let's now switch to the permanent employee class. Notice that we have still retained the inheritance of employee base class over here. Also, we have created a new override method for getMinimumSalary and returning some amount in this getMinimumSalary method. Now let's focus on the temporary employee class. Even in the temporary employee class, we are inheriting the same base employee class, which is an abstract class, and overriding the getMinimumSalary method with some value. Now the major change is in the contract employee class. If you take a look at the contract employee class, we are inheriting only the iEmployee method, which retrieves the minimum salary of the contract employee. We are not inheriting the bonus iEmployee bonus interface since contract employee doesn't have bonus to be awarded. Let's now switch to the main program. If the requirement is to get those employees which are eligible for bonus, notice that I have changed the main program and added subtypes of permanent and contract employees to the employee list. And in runtime, we are invoking the base employee class to get the minimum salary and bonus of the eligible employees. Now, if I try to add this contract employee to the list, it throws a compilation message stating that we cannot convert the contract employee class to base employee class. Now, if the requirement is to get minimum salaries of the employees, we need to have the end contract as iEmployee, which means we need to create list collection with iEmployee object. Notice that we are able to add all the employee types as all of them are implementing the iEmployee interface. Let's run this application. Look at that. We are able to adhere to the guidelines of Liskov substitution principle without any runtime errors. I believe now you have a good idea of implementing the Liskov substitution principle. In the next session, we will discuss dependency inversion principle. Till then, thank you for listening and have a great day.